Okay, so for this one, I see a right triangle. I know certainly for the first one when they're asking us for the rate of change in the height, I'm just going to be working with a version of the Pythagorean theorem. Okay, so what are they telling me? They're telling me it's a 10-foot ladder. X is changing, Y is changing. Y is the height, we'll call it. They're telling me at the time when x equals 6, we're looking for dy dt in this case, or dh dt. Okay, and they're telling me dx dt, pretend it's a dt, is 24 feet per second, and that's how fast that's sliding. We're looking how fast that's sliding down. And of course, this is a constant. This is 10. That's not changing any distance. So we know from the Pythagorean theorem that x squared plus y squared equals 10 squared. Now I'm going to take the derivative. It's going to become 2x, but we're taking the derivative with respect to time, so I have to do dx dt plus 2y dy dt equals the derivative of 10 is 0, but I want to know, as I know that it is 0. Okay, so good. So then what do I know? Well, let's see. I'm looking for dx dt. I'm looking for dy dt, and they told me dx dt. So let's substitute in what I know. So I know one thing to keep in mind is that, yes, you can use the Pythagorean theorem. We know this is 10. This turns into 6. How big is the height? Because see, in my derivative formula, I want y. Well, what I'm hoping you learned at some point in time, yes, you can do the Pythagorean theorem. You can do 100 squared minus 6 squared, take the square root, get the answer. But I'm hoping somewhere along the line you learned about 3, 4, 5 triples. Those are sides that work in a Pythagorean theorem. So notice that if you match it up, the 5 is 10, the 3 is 6, so it must be this side here is 8. So it's just a 3, 4, 5 triangle that's been multiplied by 2. So what do I have here? I know 2 times 6, they told me, and I know dx dt is 24. And then plus 2 times y, and we just decided that y was 8. And I'm looking for dy dt. And that equals 0. So now let's do some multiplication here. Let's see. So I've got dy dt equals negative 2 times 6 times 24. And yes, I could multiply that out a little bit. Divided by 2 times 8. Well, what I'm seeing here is the 2's cancel out. 8 goes into 24 3 times. So negative 1 times 6 times 3 is negative 18. What is this? Feet per second. Now, the only thing you got to pay attention to, what I noticed, no, they didn't do that here. Okay, what I've noticed with the My Math Lab is they might ask, how fast is it moving? And that's implying a speed. I'm looking at this, and they're saying, what's the rate of change? So they aren't really talking about a speed. They're talking about a velocity. And it looks like when I entered it in, it took the negative 18. So that's part A. That's finding how fast the height's changing. For part B, what's the rate of change in the area of the triangle form? So I see I've got X, I've got a Y, I've got a 10, 10. So the area of this triangle is 1/2 the base times the height. So, and that's area. And I'm looking for dAdt, right? Because they want the rate of change in the area. So let's take the derivative, dAdt, with respect to time, of course. And then I see a product on the right-hand side with a constant. So the constant just comes along for the ride. So x times dy dt plus y times dx dt. And we already found out that dy dt was negative 18, right? That was from our last problem. They told me dx dt was 24. So what's the rate of change in the area? It's going to be 1/2 times 6, because that's what it is at that instant time, times, what is it? It was negative 18 plus y, which is 8, same situation, times dx dt, which is 24. And then we're just going to multiply this, and let's see. I got 42. Now, the units are always important because we're trying to find the rate of change of the area. We're doing square feet per second. Yeah, because it's area. Okay. So that's part B. So then we've got the rate of change in the angle between the ladder and the ground. So that's the angle we're talking about. This is a fixed 10. That's our x. This is y. Now, we could use a lot of different trig ratios here. We could say that because we want d theta dt, right? So, I mean, we could use tangent. We could say the tangent of theta equals y over x, but that gives us two variables, and that makes it more complex. We could say cosine of theta equals y over 10, and that wouldn't be impossible to do. We could also do sine. That would be cosine would be x over 10, and then we could say sine of the angle equals y over 10. So I think what I did earlier, let's see, I think I did, I decided to use cosine. I decided to use the cosine one. So that's what I'll do. So I know the cosine of the angle equals 1/10 x. Now what's nice about writing x over 10 is 1/10 x. Now I could just use the power rule on that side. So let's go ahead and start doing some derivatives. So the derivative of cosine theta with respect to time is negative sine theta d theta dt. I wrote dy dt, wouldn't you know it? Equals 1/10 times dx dt. And if we divide, so I'm looking for d theta dt. So I'm going to divide both sides by negative sine of theta. Times negative cosecant theta, right? Because the reciprocal of the sine is the cosecant. Now we're just going to substitute some things in. Now remember, this is all that same instance of time. That's 6 and that's 8. And of course, we get the hypotenuse at 10. So we're going to do 1/10 times dx dt, which is 24, times negative cosecant. Well, cosecant is hypotenuse over opposite. So that's negative 10 over 8. Now we're just going to evaluate this. Well, some things I can see. I see it can cancel out that 10 and that 10. I see I can cancel out that 8 and that 24, and that becomes 3. So I think we're set with everything except d theta dt is, let's see, well, right now I'm getting negative 3 radians per whatever the unit of time is. I think it's minutes, but don't quote me. It might be seconds. It's pulling in no, it's not. It's a ladder sliding, so it's probably seconds. What did I get earlier when I did this? I guess I didn't write it down. So I'm pretty sure I'm right, though. Okay, so that's that problem. Okay, so for this one, one flag comes out at me. Sometimes you want to be talking about the angle, and sometimes you still want to just be using a right triangle Pythagorean theorem thing. Now, in CIB, they're talking about the rate of change of the angle, so that tells me we're going to write a trig relationship for that. For A, though, this is strictly just another Pythagorean theorem. Now we have this distance is changing, this distance is changing, this distance is constantly fixed at 6. So we don't have to worry so much about a y or dy dx or dy dt. We just have to worry about the horizontal distance in the rope because the rope's changing. Now they do tell me that the rope is being hauled in at the rate of 2 feet per second. So ds dt is going to be a negative 2. I'm gonna caution you though that my math lab, my lab, when they ask how fast, see how it's asking how fast? That's a speed. I got it wrong the first time I tried it because I kept it as a negative because it is a negative because that distance dx dt is what we're looking for, and that is decreasing, so technically it should be expressed as a negative, but because they're asking how fast, we're talking about a speed, not a velocity. Okay. So what do we got here? So I see s squared equals x squared plus 6 squared, because remember the y is not changing. That's a constant fix. So when I do these kind of derivatives, I mean, you certainly could take a square root and work with the square root. In fact, some of my math lab exercises do want you to do that. Well, they do it this way. If you do the walk me through it, they do it what I'm going to do, but then they go the extra step of solving for the whatever variable. In this case, it would be solving for dx, and then substituting in what we know. I mean, I do it this way. I recommend you do it this way, but that's your call. And you can follow what they do. So the derivative of s squared is 2s, and then you can do it the chain rule, ds dt, because it's an implicit differentiation, equals 2x dx dt. And then, of course, y is not changing, so that's 0. That derivative is 0. Now, let's substitute in what we know. Now, again, it looks like, let's see, they're telling me this is a fixed 6. We're looking at the rate where there's 10 feet of rope still out. So here's that's 10. And again, I'm seeing a 3, 4, 5 triangle. So the 5 is the hypotenuse, the 3 is the vertical 6, and then so this has to be 8. I mean, you can use the Pythagorean theorem too. There's nothing wrong with doing that. So let's substitute in what we know. We know 2 times 10, and ds dt is negative 2, isn't it? Equals 2 times 8 times dx dt. And that's what we're looking for. Let's see if I can't slide this down. Oh, I can. So what is that? That is, now I'll do it this way, but I'm also going to talk about how when I do these kind of problems, I don't always multiply at the end because I see what I'm dividing by. But we could write this as negative 40 equals 16 dx dt, and then divide by 16. So I get negative 40 over 16, and of course we want to simplify this. I mean, you could write it as a decimal, but it's a nice fraction, so why do all that work? I see a greatest common factor of 8, right? So negative 5 over 2, and if your version of my math lab is asking this, you'll want to write that as dx dt equals positive 5 over 2, even though technically it's negative because it's the distance is decreasing. But they're asking for speed too, how fast. So that's that problem. Now let's hold on to that. Okay, then for part B, what's d theta dt is what they're asking us, right? How fast that angle decreasing. Here, I'm going to write that up here, d theta dt. And let's erase that. So there's a couple of ways to go with this. We know this is a fixed side, and we want to know that angle. So we could say, here's the opposite side, here's the hypotenuse. I could say the cosine of theta equals 6 over h. I could say the sine of theta equals 6 over h. I could also say the tangent of theta equals x, which is my O, over 6. Now, to me, I see something where I either have to use the power rule, like 6h to the negative 1, and that'd be the same for the sine, in which case I'll end up with a fraction. I could also think of this one, 1/6 x, and that's pretty easy to take the derivative of. So when I do these, you can get the correct answer using any of these three. I mean, you could probably use the reciprocal functions too, reciprocal ratios also, but to me, I think the tangent looks easiest, and that's what I'm going to choose to use. So let me clean this up a little bit. Let's clean that up a little bit. Let's clean that up a little bit, except I'll probably just have to redo everything, so I'll just erase it all. While you're watching me erase, so tan theta equals 1/6 x. So now we're going to take the derivative. So the derivative of tangent is secant squared. And we're going to do d theta dt, and that's the variable we're looking for, right? And the derivative of 1/6 x is 1/6 times dx dt. Of course, we have dx dt from before. And dx dt. All right, I'm looking at the answer and writing into dx dt. And so we can do a little bit of solving here. Well, we have to? I mean, maybe I should just do it from here. I know that secant squared theta can be rewritten as the secant of theta squared. I usually will do that. And I know the secant is a fraction. If I come back and look at my triangle that I drew over here, it might be easier to think of this as a 5, 4, and 3, because now, so when I write the secant of theta, and remember, this is theta here, 3, I don't know why I wrote 5. That's going to be adjacent, hypotenuse over adjacent, which is 5 over 3. And then I'm going to square that. So why don't I just, let's see what I can move here. Okay, well, I can move that. Can I move this all up? I can, just give myself a little space. And that's squared, so that's 25 over 9 d theta dt equals 1/6 times negative 5 over 2. Now here I am going to take it negative. They aren't asking me for a speed, so I almost think using a negative is all right. So that's going to give me, here, let's go make some jumps here. D theta dt equals negative 5 over 12 divided by 25 over 9, which is the same thing as multiplying that by 9 over 25. And then let's do some simplifying here. I can divide 3 out of each of those. That 5 becomes a 1, and that becomes a 5. So I'm seeing negative 3 over 20 radians per minute. I think it's per minute, isn't it? And I believe that was the right answer on the when I got this version of the test. This came of this question. This came from the textbook, and that they usually include one of those from the textbook that's in the work. So hopefully you get something where you get to do some new work on it, not just copy down these answers, because that won't benefit you really. Okay, let's see. This one I did wrong. I did a couple of things wrong with it the first time I tried. It says, at the instant in time when the balloon's 65 feet up, the bicycle is moving at a constant rate of 17 feet per second. So dx dt equals 17. So that distance is increasing at 17. This distance is increasing at 1, and that was the mistake I made. Or did I say increasing? Yeah, I hope I said. So dH dt or dy dt equals 1 feet per second, and this is s, and we're asking to be what they're asking us to find is to find ds dt. So what do we have here? Well, I don't see anything but angles. I just see a right triangle. So if this is x and this is h and this is s, I can say s squared equals h squared plus x squared. And now let's do some derivatives. So 2s ds dt equals 2h dh dt plus 2x dx dt. And let's see, I know dx dt is 17, so that's good. I guess what I want to find out is, well, I see I got to find an s, an h, and an x. Oh, excuse me. Let's see. I've got a triangle here. I know it's been 3 seconds later, and this bicycle is traveling at 17 feet per second. So 3 times 17 is 51. This initially was 65. And the problem I did my first time is I just used 65, ignoring the part that the height's increasing 1 foot per second. So and it's been 3 seconds. So this is no longer 65, but now it's at 68. And then if I want to find this side, I don't know of a slick triple for this. So I'm going to do 51 squared plus 68 squared. And then take the square root. I'm just thinking, let's see, if I divide, is this divisible by 3? No, because that's 14 when I add those, and 14 is not divisible by 3. So I've got some miserable value here. So this worked out to be here. I'm gonna erase this just because I'm running out of screen real estate here. That worked out to be the square root of 7225. Does that add? Is that rational? I don't know. Probably not. Oh, it is. It's 85. Oh, all right. I like it when that works out. Okay, so I think we're ready to cook with gas here. Let's see. Can we shrink this stuff up a little bit? Yeah. I don't want to shrink that up because I'm going to be able to read it. So we want to know dsdt, right? So what do I've got here? I've got the derivative. I'm all set with that. So let's substitute in what we know. We know 2. Now I believe this is the problem on MathXL. They want you to solve for the derivative. And I wrote in that with the dh's and dt's as variables. I didn't actually substitute in values. I think they want you to do that. So I know it's going to be 2 times 85 times ds dt. Actually, I'm not going to write the variable. What they want you to do, maybe I'll back up here just a minute here. Let me, can I delete something without destroying the whole mess? That I can. Okay, so what they're going to ask you to do is do 2 times the square root of x and y, so x squared plus y squared. They call this x, they call this y. Equals 2 times, what is it? It's y, I guess. 2 times y times dh dt is 1 plus 2 times x, because x is changing. And dx dt is 17, right? So what they ask you to do to solve this, I'm missing the ds dt here. They want us to solve this for ds dt. So what we do is, for this first problem on MATLAB, my MATLAB, is you're going to write it as, let's see, the 2's cancel out, right? I'm going to divide everything by 2. So I don't have to worry about the 2. But they do want me to write it as 17x plus, in this case, 1y over the square root of x squared plus y squared. And that's that first question. When I did this and I got it wrong, I had left the 17 as dx dt, and I had written in a dy dt also. So that's what they're looking for the first part. Then you can substitute it in. I'm going to backtrack a little bit because, I mean, I guess I could. I don't have to. I could substitute in some values right now. Why don't I? I mean, I do have them. But so I know that it's going to be 17 times 51 plus 1 times 68 all over the square root of x squared plus y squared. Well, I think that worked out to be 85. And that's going to be my ds dt. And then you just calculate that. And so that gave me 935 over 85. And when I did that division, I got 11. And the units are 11 feet per second, I believe. Okay, so it's not too bad. I think, I mean, you certainly could come back and work with the radical in the start, but squares or radicals are a pain, as you've learned. So I would recommend you do write out the Pythagorean theorem, then just do a bunch of implicit differentiation. Makes it a lot easier. Okay. This is a problem. I didn't have any problem solving it, but this is a problem when I teach this course. When I teach this course at Oxbow, my textbook has this exact same problem or a variation of it, and I always have to do it for folks. So I figured you folks are probably some of you will run into the same issue. So let me record a video about this. So I know that the coffee is draining from this coffee filter at a rate of 10 cubic inches per minute. So if I'm doing this from the cone's perspective, the coffee filter, I know that dV dt equals negative 10. If I'm doing this from the coffee pot perspective, dV dt is a positive 10 because it's filling up. Okay. Then now on the filter, the diameter or the radius and the height is constantly changing. On the coffee pot, the diameter or radius isn't changing, but the height is. So, and some things you want to remember: the volume of a cylinder is 1/3 pi r squared h. The volume of a cylinder is a. Did I say cylinder? Yeah, the volume of the cone is 1/3 pi r squared h. The volume of the coffee pot's a cylinder, and that's pi times the radius squared times 8. Of course, for this coffee pot, the radius is never changing. The radius is going to be 3, right? So we can set up an equation. The volume of the because the first thing they're asking me to do is work with a coffee pot, right? So that's going to be let's see, 3, so 9 pi h. So that's the formula for the volume of that coffee pot, and it's in terms of h, which is nice because they're asking us to find dh dt. Sometimes we have to do similar figures or similar triangles and do some elimination. That'll work out on the cone. So I know dV dt is positive 10. My only other variable is h. We'll find that, and they're telling me when is the volume in the cone. When the volume of film and the height in the cone is 5 inches deep. Now you're thinking, oh man, I'm working with a coffee pot. How do I figure out what the height of the coffee pot water or the coffee in the coffee pot is when the height on the cone is 5 inches deep? Well, I hope you notice this is a linear function. We take the derivative of this, h isn't going to matter. So that's the cool thing about it. So let's take the derivative. dV dt equals 9 pi times the derivative of a linear function is just the 9 pi in this case, and then we got to do dh dt, and that's what we're looking for. So what do I know? I know that dV dt is 10. So 10 equals 9 pi dh dt. See, we don't even care about the height of the coffee in the coffee pot. We just want to know how fast it's changing. So isn't that 10 over 9 pi? And I don't remember if my math lab wanted this as a decimal or if they wanted it as a fraction. But there's the exact value. And we know it's positive too. That's nice that it's positive. But again, because it's how fast, they're talking about a speed. So even if it were negative, we would just write the positive. So that's the rate at which the height in the coffee pot is changing. And then we want to know how fast is the level in the cone falling at that point in time. Well, let me do some cleaning up here, and I'll come back and do that. Okay, so one thing that we got to deal with this cone is I know the side view or the cross section is a triangle. We know that the radius is 3, and I'm not going to worry about the diameter. I need the radius for the formula. And this is h. This is 6 when it's full, right? So I know that the radius to the height is always going to be in the ratio 3 to 6 or 1/2, right? Let me write that as 1/2. And then we want to know dH dt for the cone, and I know the volume of a cone is 1/3 pi r squared h. So I don't want to be working with the radius in my equation. I just want to be working with heights. So isn't let's see. Let's solve this for h. So I multiply h and multiply by 2. So isn't h? No, I want to get rid of the r. So I do this often. I was going to write h equals 2r, but that will let me replace the h with r, and I don't want r, I want h. So won't r be equal to h over 2? R equals to h over 2, or 1/2 h. Because if I multiply by h to move it away from the r, right? And now if it's looking for it to be squared, so isn't that going to be 1/3 pi times 1/4 h squared times another h? So the volume equals pi over 12 times h cubed. There we go. Now we've got a formula for the volume in terms of h. Now let's take the derivative. Let's see, can we move that up? So dv dt equals, bring down the 3 and the 12 cancel, so I get pi over 4 h squared dH dt. Now we know the height in the cone is 5, so we can just do some substituting. Now, they are saying how fast. I know the volume in the cone is falling, decreasing, so I'm going to write in -10 just because I'm more comfortable doing that. I probably can ignore the negative because they are asking about how fast. But now let's do some substituting. Pi over 4 times 25, because it's 5 squared, times dH dt is what we're looking for in that cone. So now let's do some cleaning up. Let's see, that's -10 equals, let's see, that 2 cancels, make that 2. So negative pi over 2 times, that's 25. Dan LeMay, you messed up. You're probably saying, what the heck is he doing? Not enough coffee is what the problem is. It's a problem about a coffee pot, and I don't have enough coffee. So 25 pi over 4 times dH dt. So I'm going to divide -10 by -25. Where is that negative? It's positive. I knew it should be negative. I knew the height should be negative. The dH dt should be negative because it's decreasing. So I'm dividing by 25 pi over 4, which is the same as multiplying by 4 over 25 pi. And then let's see here, what cancels? I can cancel out a 5 out of that, a 5 out of that. So isn't that -8 over 5 pi? So that is an exact value. Now, as I said, I think my math lab is looking for how fast, so we won't worry about the negative. But that's how fast the cone, that's the rate, that's dHt, that's how the rate at which the cone's height is decreasing. The coffee in the cone and height, or the water in the cone, I guess, height is draining. Okay. All right, so this question always has people asking me for help, and so I figured I'll walk you through this one. It's a bunch of similar triangles is what it really is, but it's a little more complicated with that because they're throwing a lot at us. One thing I know that this solid red line is the 16t squared. That's how far that ball not how fast, that's how far that ball drops in that period of time. And then this dotted red line, we can think of that as 50 minus 16t squared, right? Because the pole's 50 high. Now this is 30 feet, this is x feet, and that changes because as that ball drops, that shadow length gets smaller. You can see that red arrow there. So what we can do is we can set up, do you see the small triangle here? And then do you see the bigger triangle here? So what we have is 50 is to 30 plus x as 50 minus 16t squared is to x. Now, the first thing I did is I noticed in all these variables, and I know, well, they also tell me that t equals 1 half a second later. So let's find x. Let's see how long, after 1 second of drop, let's find how long the shadow is, because we'll need that for later on. So I can say that 50 over 30 plus x is equal to, let's see, if t equals 1 half, that's going to be 1/4, and 1/4 of 16 is 4. 50 minus 4 is 46 over x. Looking a little more tame. Now I can just do the cross products. 50x equals, let's see, and then I get to distribute here. I'll write it out. What am I doing? I'm doing 46 times 30 plus x, which gives me 50x equals 46. Let's see, where did I do that? $46 times 30 is 1380, and plus 46x, right? Because I'm distributing both of those. So it looks like I need to bring the 46x over here. That leaves me 4x equals 1380, and I divide by 4, x equals 345. So that we want to hold on to because we'll need that for later on. All right, so now we know x. Now we got to find how fast dx is. We're looking for dx, dt, right? We want to know how fast that shadow length is changing. Okay, so let me clear some stuff up here. Okay, so I can't get rid of that 50. I can't get rid of that black proportion without deleting everything, so I'm going to leave it there. We'll just ignore it. So now I'm going to do the derivative of that original proportion, the blue 50 over 30 plus x equals 50 minus 16t squared over x. So I see on the left in that blue here, I'll even change to blue. I can rewrite that as 50 times 30 plus x to the negative 1, and that'll save me from doing the quotient rule there. So the derivative of that is just applies the power rule. And then the chain rule, which of course is just 1, so I don't have to worry about that. So here's the first part of the derivative. It's going to be 50 over 30 plus x to the second power. Now I've got to do the derivative of the right-hand side, and that is a quotient. I can't clean that up any further. So the bottom times the derivative of the top minus the top times the derivative of the bottom dx. I just realized I forgot to add a dx dt over here too, because I had to use the chain rule on that bottom. All right, and this is all over the bottom squared. So what does that give me? That gives me, here, let me consolidate things. Oh, okay, now I know x. I know x is 345. I know t is 1/2. Let's substitute those values in, and it should only leave us the dx's left for the variable. So I've got, let's see, negative 50 over, let's see, x was 345, so 30 plus 345 is 375, and I have to square that, and there's a dx dt here. On the right-hand side, I know t equals 1/2, so 1/2 times negative 32 is negative 16. Negative 16, and I know x is 345. So let's multiply those, and I get negative 5520 minus, and then of course I know t equals 1/2, so that just becomes 46 times dx dt, all over 345 squared. Now I'm not going to write that out. So I see two dx dt's, one on this side, one on this side, but this one's locked up with that denominator. So I'm going to multiply both sides by this 345x squared, 345 squared times this, and I'm going to divide this with my calculator and get a single answer. And of course, I've already done that. I'm getting negative 42.32 dx dt equals negative 5520 minus 46 dx dt. So now I'm getting more simplified here. That's looking promising. I'm gonna add 46 dx dt's to both sides. That gives me 3.68 dx dt's equals negative 5520. Now I'll just divide both sides by the 3.68, and dx dt equals negative 1500 feet per second. And that's how fast that shadow is decreasing. So let's see if you can do that same thing with the WebAssign version. Some different numbers, but it's the same process. Okay, here's another one. One thing I want you to notice is ask how fast my math lab is going to look for the speed, the positive, not the negative. At least I'm pretty sure, as I recall, that's what they asked. Because I got it wrong the first time I put in the negative. But maybe not. I'll show you the negative, and then you'll have to play with that and see. So we've got what's going on here is we've got a solid sphere of iron, and it's got a diameter of 8. That makes the radius 4. Then it's got a layer of ice that's building up around it. Presume that's uniform. So that ice is x thick, and it's sublimating or melting, right? And we know that the volume of this whole sphere, remember that iron sphere is in the middle, so we're going to assume all of it, with the ice included, the full sphere. So R for the full sphere is 4 plus x. So, and we know the volume of a sphere is 4/3 pi r cubed. So let's go ahead and substitute 4 plus x for r. So v equals 4 over 3 times pi times 4 plus x cubed. Now let's take the derivative. So dv dt equals 4 pi times 4 plus x squared times 1 times dx dt. Now, I believe in My Open Math, as I recall, they ask, what's the surface area? Well, that just so happens 4 pi r squared is the formula for the surface area of a sphere. The derivative of the volume, kind of cool, right? Have you made the connection that if I have the area of a circle and I take the derivative of that, I get 2 pi r, which is the formula for the circumference of the circle. So that's pretty cool. If you haven't noticed that yet, make a point to see that. I just think that is cool the first time I ever saw that. So let's see. I think I'm ready to go. Let's substitute in what I know. I know this is negative 10 because it melts at a rate. That's a volume. equals 4 times pi, and x is 2. So that's going to be 6 squared times dx dt. Let's move this up. So I'm going to divide both sides by, let's see, negative 10 over now 36 times 4 is 144 over pi equals dx dt. And of course, I see that we can take a 2 out of everything. So negative 5 over 72 pi is the answer for this, according to the back of the book. So you'll just have to play around with whether Math Excel wants a my math lab or my lab, that's what it is, wants that as a positive or negative. And those are the problems that I think usually gives people a hard time. I posted some other related rate questions as things you can do for points. I recommend you do them because you never know what I'm going to ask you in the exam and what your professors in the future are going to expect of you. So those are pretty common ones you'll see. Okay, and don't hesitate to ask for help.